So what exactly is work? According to Britannica, it's when you apply a force through something in distance. As explained by Terra, energy is what's required to do that work. And explained by Dunn et al., power is how quickly that energy is used. Simple, right? Now, let's put this into action. First, let's jump. Literally, let's jump to the world of bungee jumping. Imagine standing at the edge of the platform 50 meters up. You're packed with gravitational potential energy. That's the energy you have simply because of your height. And it's calculated using the equation. Potential energy is equal to mass of the object times acceleration due to gravity times height of the object above your reference point. As you dip, that potential energy starts transforming into kinetic energy, or the energy of motion. You flow faster and faster as the cord stretches until it fully stretches and starts storing all that energy as elastic potential energy. At this point, the energy stored in the stretched bungee cord is given by elastic potential energy is equal to 1/2 times kx squared, where k represents spring constant or elastic constant and x represents the displacement or stretch. Once you hit maximum stretch, kinetic energy is zero, but the energy hasn't disappeared. It's just stored in the cord. The conservation of mechanical energy tells us that the total energy stays the same, just changing forms. And thanks to this energy transformation, the jumper bounces back up, safe and sound. Have you ever thought about the difference of walking and running? Here's where the work energy theorem comes in. This theorem tells us that the work we do is equal to the change in kinetic energy, calculated as work is equal to the change in kinetic energy is equal to 1/2 times final mass velocity squared minus 1/2 times initial mass velocity squared. When you run, you move faster, which means your velocity is higher. This leads to a bigger change in kinetic energy, meaning more work is required. You're using more energy, which is why running feels more exhausting. Walking, on the other hand, requires less energy since your velocity is lower. You're still using energy, but not as much. So, over long distances, walking is more efficient. And let's not forget about power, the rate at which you use your energy. Runners burn more energy in a shorter time, so they're using more power compared to walkers who take it slowly and steady. Whether it's the adrenaline rush of a bungee jump or the everyday decision to walk or run, the concepts of work, energy, and power are in motion around us all the time. From storing energy to using it efficiently, science gives us the tools to understand how we move through the world. Remember, science is in everything you do, so keep moving and keep learning.